Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muhammad bin Muhammad Zaidi. My metric number is 2010910008. Today we will present the water quality system for closed fish farming mini project. I will present the introduction of the mini project. Nowadays there are a lot of disasters happening everywhere, such as disease outbreak, national disaster, and many more that taken a lot of life and leading cause of food insecurity. Food security exists when all of the people at all time have physical, social, and economic access to sufficient food. So to ensure the food security, if the food supply is running out when disaster occur, we have made a system that monitoring the water quality system for closed fish farm. This closed fish farm is to breed fish and eat its source of food. In this mini project, we using pH sensor, water level sensor to detect the level of water. So the next is problem statement. This time, we can see that when disaster occur, people don't have sufficient food supply for their living. This project is necessary to make a preparation for it. The current problem faced for fish farm is the value of pH. If the pH value is not suitable, this will affect the growth of the fish. Besides, the water level will also need to maintain at the appropriate level. If the water level is insufficient, the fish even will die. So the objective project is to maintain high grade of water in fish farm, to monitor the value of pH in fish farm, next to monitor and maintain the water level in fish farm, and to ensure that the food supply is in a good condition. So I will pass to the next presenter.
Okay, thank you Muhammad. Okay, my name is Muhammad Haziq bin Muhammad Fazil. My metric number 2010910003. I will present on chapter 2, planning. Okay, this is our first chart. Okay, this is our first chart explanation. For solution, find an appropriate solution to solve this problem. For planning, observe and analyze the solution in order to solve the problem. For state diagram, using a more model state diagram. For state table, to produce the flip-flop state table. For Carnot map, to reduce the quality of bit or logic circuit produced by a state table, create a simplified equation. For logic circuit, simulate the simplified equation by using digital software. The project title, our project title is water quality system for closed fish farming. Project brief summary. The system will use to monitor the acidity of fish farm and water level at the fish farm while controlling the buzzer, siren, one valve and water pump. Number of inputs and their functionalities. We have three inputs. Number one is water level sensor one. Input type is submersible water level transducer sensor. Their function is used to indicate the water at higher water level. Number two, water level sensor 2. Input type submersible water level transducer sensor. Their function used to indicate the water at lower water level. Number 3, pH sensor. Input type pH meter with infrared light beam. Their function used to monitoring the acidity of the water. Okay, number of outputs and their functionalities. We have three outputs. Number one is buzzer. Output type buzzer sound. Function they are used to give warning by using the buzzer sound. Second, valve. Output type signal to valve controller. Function used to control water release valve. Number 3, water pump. Output type signal to water pump controller. Function used to entering water in fish farm. Inputs and outputs relations. Number 1, buzzer. Relation active when the acidity of water increase between 6.5 to 1 pH value. Deactive when the pH value maintain in level of pH 7 value. Second, valve active when water level at fish farm increase above the water level sensor 1. Deactive when water level in the fish farm below the water level sensor 1. Water pump active when the water level decrease below the water level sensor 2. Deactive when water level reach the water level sensor 1. I will pass to the next presenter.
Okay, thank you Haziq. My name is Muhammad Afiq bin Haizan and my material number is 2010909991 for the chapter 3 system design. So for the state diagram we choose more diagram, which is we have four condition such as normal, acidity, high and low. For the input we use acidity, we use symbol C. For the level 1 which is high, we use L1 symbol. For the level 2 which is low, we use L2. For the output buzzer, valve, water pump, we use A, G1 and G2. For the state table, firstly to create the state table we must fill up the present state, input and output. So for the next state we actually use QAN and QAN plus to get the flip-flop input, which is JA and KA. For the present state QBN, we relate to the next state QBN plus to get the flip-flop input for the DB. For the Karnaugh map, we divide into two parts, which is KMA input and KMA output. For the KMA input, uh, we use KMap to get the equation of QAN plus, which is this equation. And for the QBN plus, we we use the KMap to get the equation. Uh, for KMap output, which is buzzer, valve, and water pump. This is the equation for the output A, G1, and G2. Uh, so next, the schematic design. We create the circuit in software simulator, and this is the circuit connection of the water quality system for closed fish farming. Thank you.
Assalamualaikum. My name is Muhammad Fidal Muhammad Rizan. My metric number is 2010909999. So for chapter 4, result and discussion, there is the figure 3 which shows the condition of circuit when the buzzer is on. Based on figure 3, we can see from the time diagram that the buzzer A is on, which valve G1 and water pump G2 is off. The buzzer will start functioning when the input, which is the pH sensor, detects acidity of water. The input from pH sensor will trigger the buzzer so that it can alert the operator in the control room to neutralize the pH value of water in fish farm. Here is the figure 4, which is shown the circuit when the valve is on. From here we can see the time diagram that the valve G1 is on, while buzzer A and water pump G2 is off. The valve will start functioning when the input, which is the submersible water level and transducer sensor, which is sensor 1, detect the level sensor at high water level in the fish farm. The input from transducer sensor will trigger the valve if the water continually enter until the level of water in the fish farm start to reach higher level. Valve at the fish farm will open to let amount of water flow out from the fish farm. This is to ensure the water from the fish farm overflow. Here is the figure 5, which shows the condition of circuit when the water pump is on. From here we can see, from the timeline we can see that the water pump G2 is on, while buzzer A and valve G1 is off. The water pump will start functioning when the input, which is the submersible water level, and transducer sensor, which is sensor 2, with the low water level in the fish farm. Transducer sensor, which is input from L2, will trigger the water pump if the water in fish pump continually dropping until the level of water in the fish pump start to reach lower level. So the water pump will on to entering the water in fish pump until the water level exceed the sensor 1. This is to ensure the water from fish pump decrease.
Thank you, Fido. So the last part of the presentation is conclusion. So what is project impact into the society? When disaster occur, our food source will be cut off. So by running this project, it provides a readily available high protein source to the society. So what I can conclude from this mini project, it was successfully designed and implemented, in which small components are built first and then added to a large component until the design is complete. The design of this mini project begins with the lowest level of design, which is state diagram, which is more model. The next step is we build the state table. The condition from the state table will arrange into Carnot map format, KMap, allowing reduction in the circuit. From the map, the expression need for the design were carefully derived and used for the D flip-flop schematic. This step is crucial since one small error will affect the output of the mini project. So that's all presentation of water quality system for closed fish farming mini project from us. Thank you.